Yeah, so once we have finished with our calculation that pertains to the major elements, then we have an idea as to the type of bolt that we wish to use, and also determine the spacing, that is the pitch of our bolts, and also the end and edge distances. The next is to be able to carry out strength checks. Yeah, because for our structure to be solid, as it were, the looser the structure is to carry, those loads should also be subjected to the connections that pin or that bring these elements together. So if you are expecting our beam to carry a particular load where we are able to get the reaction, so that reaction where it's connected to the column may be translated in the form of what? Shear force. So that shear load, how the connection between the column and the beam, how they interact by way of the connection, we should be able to check to ensure that the connection will be able to resist the shear. And also um, the bolt also, we should check to ensure that it's able to what resist it has the enough load, that is the bearing load, or the bearing strength to be able to resist that same load that the the connection is coming to resist. And also the connected parts, so if it's a beam and a column, we are again looking at uh, where the connection is made of, maybe work plates, so or some angle bar that is connected to the beam and to the column, how these two are connected. So the plates of the what? The angle bar and the flange of the column. We want to check to ensure that they have enough bearing strength to resist the load that is being carried. Okay. And of course, if we estimate that the connection is going to resist some tension or tensile forces, the bolt on one hand should be able to have the strength to carry the tensile load. The connected part to there is a plate should also be able to resist the tension. So when we estimate a combined shear and tension, the bolt and the connected parts should also be able to resist these loads. So let's start by checking the shear, the bearing of the ordinary bolts. Those that we call the black bolts. So for a bolt, the shear capacity is computed using this formula, where PS is the shear strength of the bolt and AS is the effective area of bolt, and this is normally taken as the tensile stress area. So the shear strength of the bolt, we can see it in table 30 of the code, that is PS. So let's look at that. Yes, so we have table 30 of the code. So depending on the grade of the bolt, we have the respective shear strength. So once we identify the type of the grade of the bolt, we just come to pick the respective shear strength in megapascal. So that's table 30 of the code, where we have the shear strength given depending on the grade of what the bolts. So the next is to check the bearing capacity of the bolt, and that is given by this formula. So the bearing capacity is given by this formula, where dB is the diameter of the bolt and Tp is the thickness of the connected parts. So again, if you have two parts and one is thicker than the other, we are looking at the thinner plate. Then we have the bearing strength of the bolts, and the bearing strength of the bolts is given in table 31 of the code. So let's go and look at that too. Yes, so that's table 31 of the code. So we have the bearing strength, also depending on the grade of steel, grade of the bolts. So these are the ordinary bolts and these are the friction grip bolts, and we have the respective bearing strength in Newton per millimeter squared. So the last in our checks is the bearing capacity of connected parts. So that one is given by this formula. Again, let's see the terms. So KBS is a coefficient given in the code, and for both in standard clearance holes, which we assume are the commonest and which we assume we are using. So KBS is equal to 1 for both in standard clearance holes. Then we have the diameter of bolts. We have TP, that is the thickness of the plates. Again, if there are two plates, so the thickness of the smallest. Then we have PBS, which is the bearing strength of the connected parts. So the bearing strength of the connected parts, we have it in table 34. We go and look at it. E is the end or the edge distance, that is the one that is parallel to the stress, that's the direction of the force. And we have the thickness of the plate again, and we have the bearing strength again. So basically we try to look at these two and we pick the most critical, okay, between the two. That is, one could be from the part that is connected to the beam, and another the part that is made up of the angle bar, that is for the connection. So let's look at the bearing strength of the connected parts in the code, that is in table 32. So table 32 of the code, the bearing strength of the connected part, depending on the grade of steel that the connected part is made of. So S275, S355, or any other grade, and you have the respective bearing strengths.